Welcome to Green Money Matters, the podcast where your financial future meets the planet's well-being, bringing you the latest on climate issues and uncovering new and exciting investment opportunities that make a positive impact.
And I'm Chris Everett, your guide to sustainable investing, ESG funds, and all things green. Each week, we'll explore the intersection of money and sustainability, showing you how investing wisely can create a greener world and grow your money.
From renewable energy projects to eco-friendly startups, we'll dive deep into the companies and funds that are driving change and making a difference. Whether you're a seasoned investor or just starting your journey, Green Money Matters is here to empower you with knowledge, insights, and actionable tips that'll supercharge your portfolio and make a positive impact on the planet.
Join me as I speak with industry experts, successful investors, and thought leaders who are shaping the future of sustainable finance.
So get ready to invest with a conscience and join the growing movement of individuals who are reshaping the financial landscape. Welcome to Green Money Matters with your host, Chris Everett.
Hello and welcome to Green Money Matters. The green roof market was valued at $1.4 billion in 2022. It's projected to reach $5.4 billion by 2030, growing at a compound annual growth rate of about 16% from 2023 up till 2030. So it's a massive industry, massive opportunity. Europe's currently the largest green roof market share, followed by North America, anticipated to grow again at 15-16% per annum over the next 5 years or more. So today we have on the show Steven Peck from the green roofing industry. Now, if you want to know how to turn deserts into living spaces, how to reduce your household costs, how to reduce your energy costs, how to improve your living spaces, how to increase the value of your property, then Steven's going to give us some really great insights into how we can go about that. Hello, everybody. I'm joined today by Steven Peck, the founder and president of Green Roofs for Healthy Cities, a non-profit industry association that's devoted to spreading awareness of the benefits of green roofs, walls, and other living architectures. Steven's Canadian and based in Toronto, I believe. He's a publisher of the Living Architecture Monitor magazine, which I've read and is fascinating, and founder of the Annual International Greening Rooftops for Sustainable Communities show. Steven, welcome.
Thanks for having me, Chris.
Real pleasure. So listen, to kick us off, tell us what green roofs, living architecture, and green walls actually are.
Well, essentially, they're technologies that have been developed over the last 50 years or so that enable us to essentially grow plants on the surfaces of buildings, either the walls or the roofs. And there are a wide diversity of approaches to doing this. There are different systems on the market that have different costs and benefits, but essentially, living architecture is about combining living systems, organic systems that support life, plant life, with inorganic or non-living systems that are traditionally part of the building envelope, whether it's roofing systems that are chemical based or fossil fuel based, or various types of cladding on buildings. So it's combining the living and the non-living together, which give us living architecture.
Okay, brilliant. How did you get here? Well, how did you get up there?
It's been a long road, Chris, but I got here. Essentially, I started out my career working as a public policy consultant, and I did a lot of work on technology, innovation, and diffusion. While at the same time, I did a lot of volunteer work in Toronto having to do with our Don River, which has carved a beautiful valley through the city, which has trees and plants and as recreational space. And it has been under some development pressure So I was involved in like urban sustainability issues and restoration and conservation and advocacy to protect these areas. While professionally, I was involved in what is the role of government policy to support green or environmental technologies, their innovation, the diffusion of them in the marketplace. And then the green roof thing came along. Concept, I came upon it in 1997 for the first time. And it was like this nice mix between a technology that had been proven in Europe, but was virtually unknown in North America, that had all these benefits. And it had a lot of urban sustainability components to it. So those was sort of the marriage of those two things got me really excited about green roofs, and that's why I've spent the last close to 24 years working to develop the green roof and wall market in North America and around the world.
Okay, brilliant. Now, you've actually just been over to Berlin for the Green Roof and Infrastructure Conference. Tell us a little bit about that. What's new? What's exciting?
Well, we had a really great conference. It was hosted by the Green Roof Industry Association of Germany. The acronym is BUGG, and the World Green Infrastructure Network, which is an international organization of green roof and wall associations from around the world. And it was our first gathering since COVID. So it was very exciting. We had over 1,200 people. There were 100 plus presentations from around the world. And a huge trade show component. There's lots of companies and a robust market in Europe, which we are looking to strengthen through advocacy work with the European Union. And there are a lot of new things going on. One of the interesting things is that integration of solar panels on rooftops with green roofs. As you know, because of the Ukraine war and the reliance in Europe on Russian energy, there's been a real move politically and policy-wise to try to get Europe off of natural gas from Russia. And introduce more renewables. So there's a push for, for example, solar panels on rooftops. And there are new technologies emerging that allow those two green roofs and solar panels to come together really nicely for a win-win situation where they complement one another. That was one of the really interesting innovations that I saw at the conference technically. I
mean, I think France introduced a law, I think was it March this year or last year, actually, so that new rooftops on new buildings in commercial zones must be either partially covered by green roofs or solar panels, or obviously a combination.
Yes, I think more and more cities, Chris, are realizing that the roof space in their cities is like an asset, can be an asset in the fight to maintain a quality of life for residents in the face of climate change related impacts. The climate crisis is upon us. And we're seeing, extreme weather events in terms of intense rainfall that we've never seen before. The 100-year storm has already come 3 times this decade kind of thing. And we're seeing intense, heat and the urban heat island, which is the overheating of the city. So a number of cities have been leading the way in understanding that their roofs and the use of living architecture can help to solve or remedy many of these challenges. And Paris in particular is one of those cities, and with a particular focus on food, actually, in France. Of course.
You mean the growing of food on? you mean the growing of food on roofs?
Yeah, I mean there are some targets that have been set in Paris for food production in the city, which of course has economic benefits in terms of job creation and obviously fresh produce. And there's a reduction in food miles traveled, so CO2 emissions associated with food being trucked in from distances and so forth. And we're never going to get enough food in cities to feed cities. They're too densely populated. But we can augment food coming from far away and generate lots of benefits locally through local food production on roofs and walls, particularly rooftops.
So interesting. So let's get a little bit into the technical side of living architecture, green roofs. Explain the concept to us and the potential benefits for the environment.
Well, that's a big question, Chris.
Mm.
I mean, essentially, a green roof assembly typically involves the following elements, common elements, and there's lots of variations on a theme, but you can have water storage, which is called a blue-green roof. So you can design a green roof to hold water, and that can be like just having it pond on a waterproof membrane. But there are also systems to slow the process of water down as it drains out. So there's sort of two basic ways of doing that. And you will typically have a root repellent layer that protects that waterproofing from any roots that might try to get through and penetrate it. So obviously you want to have no leaks on your roof, and a root repellent layer is one way to do that. Then we have a drainage layer because, if you have one of those freakish 100-year storms, you don't want to have massive ponding of water on your roof. You want to have a control of the amount of water on your roof and a controlled exit of water when the system becomes fully saturated in terms of how it's engineered, whatever it's engineered for. So a drainage layer is really important. It also provides aeration for the roots of the plants. Then we have a filter cloth, and the filter cloth typically sits on top of the drainage layer, and it's designed to stop any fine particulate matters from clogging up the drainage system, that fine particulate matter that comes from the engineered growing medium. And so we don't just put soil on a rooftop. What we grow the plants in is engineered for a whole bunch of different performance characteristics, which include things like compaction, aeration, void ratio, cation exchange, and a whole bunch of technical stuff that's probably way too detailed for the show, but it's not soil typically. And it's an engineered product. And then, of course, the plants, which we have to create an environment on a rooftop that facilitates plant growth. So that means careful consideration about irrigation. Many buildings capture rainwater and you reuse it to irrigate green roofs during dry periods, for example, or they supplement with potable water. But in this era of climate change, when things are becoming increasingly unpredictable, having an irrigation system is kind of like an insurance policy to make sure your plants don't actually dry out and die. And then in terms of the plants, we've got very lightweight systems called extensive systems, which are very designed to be lightweight and low maintenance, and typically use sedums, a combination of sedums, which is a succulent plant that has evolved in very harsh conditions on rocky surfaces. So it has a lateral root system. It's very greedy for water. When it rains, it sucks up water and holds it very tightly. It's designed to withstand drought, these plants. So we see those being used at one end of the spectrum in extensive systems. And then at the other end, intensive or roof gardens could have trees, small trees and shrubs and all kinds of plants, but deeper growing medium, a different blend with more organics in it to support the plants. And they're often accessible, right? Rooftops. They're roof parks, or they're agricultural production, or, performing other functions that extensive green roofs aren't necessarily performing. So there's a range from the sort of minimalistic, lightweight, extensive system all the way up to, a beautiful landscape that you wouldn't even know potentially was on a roof with trees and shrubs and so forth. Millennium Park's an example of that in Chicago. So that's, in a nutshell, the green roof part. Do you want me to give an overview of the green wall stuff too?
It already sounds so beautiful, already. I'm picturing, these wonderful sedums. And the first thing that sort of pops into my mind, though, and I want to get into the environmental benefits of green roofs and green walls, living architecture in general. But the first thing that pops into my mind, I suspect a lot of people, is, gosh, isn't that a lot of weight? Would somebody want to live, under a green roof?
Well, you would definitely want to live under an accessible green roof, because we're seeing a lot of green roofs being built in North America on multi-unit buildings, multi-unit condominium or rental units, because it's like having a roof park, in your building, right? Which can be private and safe. and provide, you with additional recreational space. And it also, increases the value of the building. As for structural loading capacity, you with an existing building, you have to do an assessment that determines whether or not there's excess structural loading capacity in the building. And if there is excess structural loading capacity, you need to know what it is, and you need to have a map of where the various structural loading capacities are, because it could vary in different parts of the roof, or if it's a multi-level roof. And then based on that, you can determine what kind of a green roof, you're able to implement. We have systems that are fairly lightweight, down to, 15 to 20 pounds per square foot, extensive, very lightweight systems. And then we have roof garden intensive systems that could be as much as, 75 pounds per square foot or more, if you're talking about trees. So the structural loading is a really important component that has to be at the front end of a design, installation, and maintenance process for green roofs.
Okay, but I mean, in principle, there's no obstruction to putting some form of green roof on any existing building. Is that fair?
If it has the structural loading capacity to do so, it has to have the additional structural loading capacity, and that's fully saturated too. That's when after a major rainfall too. So, the number of existing buildings that can accommodate a lightweight green roof really depends from city to city, but typically it's sort of in the 10 to 20% of the roof area for existing buildings. And then, of course, if you're designing a new building to meet a mandate like in Paris, you design the structural loading capacity that you need for the green roof that you're planning. You just build it into the design.
Okay, excellent. I mean, my image of a green roof obviously is, it's a flat roof. Most roofs are sloping. Is there a potential there, or is that simply just a no-go area for everyone?
So imagine you have a roof that's flat, right? And then you start to, move it up, tilt it up slowly. At some point in time, you reach a vertical, right? Which then becomes a green wall, right? So, I mean, technically speaking, we have the capability to engineer living architecture on any slope, from a completely vertical green wall to a perfectly flat green roof. There are special considerations that have to be made, as the slope increases. There are special systems that hold growing medium in place on roofs, and there are special considerations in terms of drainage that have to be factored in. But anything pretty much is possible from an engineering design perspective. I mean, we have a green roof in Washington, D.C. that's actually like a corkscrew. It starts out flat, like a wave. It starts out flat, and then as it progresses, it turns upwards like a DNA, like a DNA or a wave, and it goes to a vertical. So it goes from a flat surface to a vertical surface, and it's all green with plants. So anything's really possible.
Excellent. So the only difference then in that case is, to my understanding, between a green roof and a green wall is, the structural considerations and presumably sort of the plant types that can actually sort of grow in that type of structure.
Yeah, I mean, there are a number of design considerations. Those are two of them. There's also with green walls, there are different types of green wall systems. Some of them are soilless, or they have no growing medium. The plants are fed through the irrigation system, and nutrients that are applied through the irrigation system. Other systems are felt-based systems that have pockets. Or they're recycled plastic containers that lock into a grid that have soil in them that hold the plants. There's a wide variety of approaches to designing green walls, but in all cases, you have to have know what the light is going to be. You have to have access for maintenance. You have to design for that. You have to make sure that that you pick the right plants for that particular environment. They irrigation systems are an absolute must for green walls. They're not necessarily required for green roofs. And there's a lot of different green wall systems on the market, like a tremendous number of green wall systems, and the approach and to them and the costs and benefits vary very significantly, to a higher degree even than green roofs.
To talk to me about the costs. So, it all sounds terribly expensive, materials, structural considerations, maintenance.
Mm-hmm.
How expensive is this?
There's definitely an additional cost to putting a green roof on a building, relative to, not putting anything on at all. And the costs depend on what kind of green roof system generally you're going to go with. Obviously, an extensive system which has 4 to 6 inches of growing medium and sedums primarily is going to be a lot less costly than a green roof that has 3 to 4 feet of growing medium and has trees and shrubs. But also the benefits are very different. So on the plus side, you're going to get more potential financial benefit from an accessible green roof. Because it's going to increase the value of your property. There are also case study examples where developers will carve up the roof into, 10 by 10 plots and sell the plots, just like they would sell a parking space in the basement of the building. They will sell a plot to one of the condominium owners, and they rent it or buy it, and they are able to have their own little mini backyard on the roof. That generates revenue. And then just having accessible green space on a building often more than offsets the cost of the green roof installation and maintenance. Like, it's from a value proposition, from a developer's perspective, it's a win, right? Yeah. Just like it's not that much different than, if you had 2 buildings side by side and one had a pool and the other one didn't, and everything else was equal. The building with the pool would be worth more, right?
Yeah.
And the units inside that building, whether rented or sold, would be worth more. It's the same thing with putting a roof park on. The building with the roof park, some research done out of Portland, Oregon, that compared condominiums found that buildings with green roofs, even if they weren't like highly manicured, intensive ones, but just extensive green roofs, were 5 to 6% more valuable than exactly the same building without the green roof. So that's one obvious benefit. Then there's a whole bunch of other benefits that come from things like extending the life of your waterproofing system. Typically, waterproofing systems in North America have somewhere between a 15 to 20, maybe 25-year lifespan, because they contract and expand with the sun's energy. They constantly flex. Heating, cooling. The diurnal changes every day, especially they're getting more intense, and they wear out. But when you put a green roof on top of a waterproofing membrane, you actually protect it you stabilize it from the expansion and contraction as a result from the heating and cooling. And that's principally what makes a waterproofing system. It doubles its life expectancy. So if you're investing in a hospital or any kind of government facility where the building's going to be owned by the public for the long term, you could eliminate 2, maybe 3 replacement cycles of that roof, the cost, by having a green roof system. In fact, the General Services Administration in the United States, which is the largest building owner possibly in the world, when they build a building, they expect that the roof will last as long as the building will, over 100 years. And they put green roofs on all their buildings now because they're protecting that waterproofing system underneath, and they don't have to rip it up, tear it up, and send it to landfill or recycle it. Parts of it, they don't have the labor involved in the expense every 15 to 20 years, right? Because the roof's going to last much, much longer. That's a big savings for some types of buildings and development. And I could keep riffing on this if you want. There's energy savings associated with a green roof. It stops heating, it reduces heating and cooling loads. There are opportunities for, active revenue generation from green roofs. We've seen lots of examples of that. I mean, there's some green roofs in Tokyo where you actually have to pay a fee to go up and see it.
Yeah.
Like you would pay a fee to go into a botanical garden. because they're like little botanical gardens with shrines, and it's phenomenal what they've done in Japan on the green roof front there culturally. As just an example. And then you've got food production opportunities, which we have green roofs where the roof space is leased to a third party by the owner of the building, and the third party pays rent to use the roof space to grow food on it.
Amazing.
And I could keep going on and on, but there's lots of ways to garner revenues and cost savings that offset the expense of these technologies. On the green walls front, for example, just to name a couple, I mean, the aesthetic benefits. I mean, one of the things about green walls is they well-designed green walls, they're really impactful, right? And they make people feel really good, particularly if they're designed with a diversity of plants. And that can have direct positive health benefits for the occupants of the building. And the health benefits can translate into things like less absenteeism if it's a commercial building, or higher levels of productivity even. And this has been studied scientifically in research. So the effect of living architecture on human beings can translate into better health outcomes, better efficiency, less absenteeism, more what's called presenteeism. People aren't daydreaming while they're sitting at their computer. And those things can translate into bottom line benefits for companies. And I could go on, but I think I'll stop there.
I love green walls. I love green roofs. Every time you see one, or you interact with one, it's always a delightful experience. I mean, we've even got not a particularly good one on the bike shed in the back of our apartment block, and it's just a small little oasis of goodness happening out there. So anecdotally, green roofs, tremendous experience. Although, do people not spend time daydreaming, wishing they were in a forest if they're staring at something really beautiful?
It's actually kind of the opposite. The research into what's called biophilic design. Biophilia is a concept that basically it's a premise that says that we are innately attracted to nature and natural and the aspects of nature, like sunlight and running water and plants and bird song, the natural things, because we evolved on the earth over the last several million years. And so the things that contribute to our survival, if you just think about this for a second, like running water, what does running water represent? Well, it represents an opportunity to drink, right? A source of replenishment. It's potentially an opportunity to eat food, shellfish, whatever, small fish, and so forth. So the things that we are sort of hardwired to desire are the things that over countless generations have enabled us to survive, right? That's hardwired into our brains. And the research is showing that it doesn't matter if you're Mongolian or Chinese or Indian or Russian, or a Brit or North American, we're all hardwired the same way. And when we design buildings that have those aspects in them, built into them, we get much better health outcomes from the people and cities. When we design cities that way, we get much better health outcomes, but we also get much better economic outcomes in terms of real estate value and, desirability and livability and all that type of stuff too. So this biophilic design aspect of that's come about and into our consciousness in the last 25 years or so is proving to be tremendously valuable. And living architectural systems, green roofs and walls, are a piece of that puzzle. It's not the whole piece, but it's one of the pieces of that biophilic design puzzle.
Tell me more about the environmental or the positive environmental impacts of green roofs. How does it help specifically?
Well, there's sort of two dimensions to that. One is the removal of a negative and the replacement of a positive, the second dimension. The negative is that a lot of the roofs that we have particularly in North America, the flat roofs. I mean, they're kind of like deserts. They're biologically dead. When it rains, they don't absorb any water. There's no infiltration, so all that water comes off of those roofs. It goes down the downspouts. Has to go somewhere, and typically, unfortunately, it goes into the storm sewer system. And depending on what city you're in, it picks up contaminants. The storm water picks up contaminants from the roads, the streets, the roofs in our cities, right? And it flows into receiving water bodies, whether they're rivers or lakes or estuaries or the ocean directly. Or in a worst case scenario, they often get combined depending on the intensity of the storm and, again, which jurisdiction you're in. Older cities typically have what's called CSOs, or combined sewer overflow events, where actually that water running off the roof mixes with the sanitary sewage, which is supposed to be going to the sewage treatment plant. And that diluted sewage and stormwater goes into the river or the lake or the estuary. And this is not particularly good for anyone. Not to mention the aquatic life forms, but it's not good for human beings. It's a waste of a resource. And so that's one big issue that we are trying to tackle in North America, is to manage urban stormwater flows. And the philosophy varies from jurisdiction to jurisdiction, but essentially the ideal is you want to capture that rainwater and use it to support plant growth, either on the land or on the roofs or the walls, because it's very valuable. Or you want to infiltrate it back into the groundwater if you're able to do so. You don't want to take all that water the millions and millions of gallons of water and, channel it into, the sewage system or the stormwater system and fire it into the lakes and the rivers, because A, it's a waste of resources, and B, it has all kinds of negative downstream effects in terms of aquatic life and in terms of biodiversity, in terms of human health and well-being, in terms of the sheer cost of managing and trying to treat or create infrastructure to support the movement of so much water. So it's much better to hold the water on a site or among a number of buildings. That's where the real innovation comes in. When you have 8 or 9 or 10 buildings a cluster, then they create a water management system, and which might include, for example, a pond, that people could swim in, and use. And so we got to think about water differently. And that's part of where living architecture comes in. So that's one of the big benefits, is thinking about stormwater very differently. Think about it as a resource. You've got to manage it. You want to capture it and reuse it on site or a number of buildings. Potsdamer Platz in Berlin is a classic example. It's a very famous development where they capture the water from a number of the rooftops, many of which are greened in the Potsdamer Platz complex, and they bring it down into a pond. And they actually have a living machine down there. They have all kinds of aquatic plants that treat the water. The pond goes up and down depending on how much rainfall. They can use the water for irrigation purposes. So they draw on that reserve when they need to, when it's dry. And then when it's really wet, they allow it to come up. So it steps up. People can have their lunch there. People fish there. You're not supposed to swim in it, but it's a beautiful, there's fountains and all kinds of really great designs around that project that really have created a wonderful courtyard for the buildings that can be enjoyed by the public or the people that work there. It's thinking differently about water in cities and designing water in a way that produces way more benefits than sticking it into a pipe and trying to get rid of it as fast as possible. And that's just the one type of benefit, the water-related benefit.
No, excellent. I mean, and I can back it up. The UK in particular has had some real difficulties over the recent years with stormwater management, the commingling of sewage and rainwater. And currently, I don't think there's a safe river or beach in the UK at the moment as a consequence. So
that's unfortunate to hear. That's unfortunate to hear, because the fact is that there are in many places around the world they have periods of intense rainfall, and then they have periods of drought or dryness, right? So seeing stormwater as a resource. I mean, historically, what happened was because of the cholera and other diseases, right? We didn't really make the connection between the health of the water and the health of human beings until around the mid 19th century, right? And so when they realized that there were all these waterborne diseases, which is what happens when you defecate into the same river that you're drawing your drinking water out of, or you process animals, by the river or whatever,
Yeah.
And people back then actually used to drink beer all the time. That's how they were able to survive, because alcohol was the fermentation process killed a lot of the negative.
Or they just didn't notice.
Yeah, but beer was a big deal back then, and other spirits, because the water couldn't be trusted, right? And so what the sort of thinking was, with public health thinking was, well, we got to get rid of all this. We have to try to manage our sewage, and that didn't happen until like 1915, 1910. That started the technologies that came into place roughly around that period, and then get rid of the water, like get it away. Move it away from people, right? That's why we have inherited all these systems of, capturing rainwater and mixing it with sewage and getting it into the river or the lake or the ocean, as fast as possible. And we need to rethink that and continue down a path that is very different, that sees that water and gray water in buildings. When you wash your hands in a sink, that water should be captured in the building and reused, for irrigating plants, for example. And the regulations and the structure around public health and water haven't really kept pace with the technologies that we now have that can manage water more sustainably in our cities and in our buildings. There's a major catch up that has to happen, because often regulations are very strident and strict, and they act as a barrier to innovation that can prove to be environmentally and economically more sustainable.
Yeah, and I guess we've also inherited, old technologies, drainage systems that were being put in place 100 years ago or more. So it's a big expense to upgrade those, I guess.
Absolutely. In fact, in Philadelphia, which is one of the leading jurisdictions in North America for green stormwater management, I mean, they have a really old. It's an old city, Philadelphia. It's one of the original colonial cities in the United States, dating back to like the mid 16th century, and they were they were having problems with CSOs and other issues in the rivers, the Schuylkill and the Delaware rivers. And they were looking at building a tunnel to try to capture all this stuff. And it was going to be like billions and billions of dollars and incredibly disruptive. The old way, the gray infrastructure way, right? Capture it all in a big tunnel and then pump it through a treatment plant in order to meet the federal regulations. And so about more than 10 years ago now, they looked at an alternative, which was to try to reduce significantly the amount of stormwater runoff in their city. And they have a plan to implement 10,000 acres of greenery in the city of Philadelphia, in schoolyards, in right-of-ways, on rooftops. And they're well into it now. It's a multi-billion-dollar green renovation of the city of Philadelphia. It's quite a miraculous development that is other cities around North America are looking to emulate, because not only are they going to get improved stormwater and water quality, they're going to get all the other benefits that come from the greening of the city of Philadelphia, health and well-being, and reduced urban heat island effect, and reduced air quality, pollution, the jobs. So Philadelphia is undergoing this amazing transformation right now around green infrastructure, living architecture, really driven by the water issue, the stormwater management issue.
Amazing. Just to go back slightly, I'd like to hear a little bit more about the urban heat island effect and the implications for carbon footprint reduction Tell us a little bit about that.
Yeah, so I mean, hand in hand, when you remove, when you develop an urban area, you're going to eliminate vegetation. And what vegetation? When you eliminate vegetation, you create a more like desert-like environment. If you think about a desert for a second, right? A desert typically gets super hot, right, in the daytime. And then it drops. The temperature drops really cool in the nighttime. And one of the reasons for that is that deserts don't have the plants that buffer the temperature swings. And the way that plants do that is that they take the sun's energy and they use it essentially to what's called photosynthesis. They create various sugars from the sun's energy, from the photons of the sun that come down, the radiation of the sun. And they reflect some of it. The green that we see in plants is actually the light waves that the plants don't want to use. They're the rejection, if you will, of the spectrum. The non-usable spectrum from a plant's perspective often is the green, which is reflected. And when they're doing that process of photosynthesis, so they can build their structures of their bodies, they basically transpire water. And when a water goes from a liquid state to a gaseous state, which is what transpiring is or evaporation is, right? It goes from a liquid state to a gaseous state. There's a net loss of energy in the system. In other words, it takes energy to do that. So the sun's energy is being used to create fuel for the plants to grow, and it's also being used to transpire water. Instead of heating up the environment, right, it's being used to do those things. So when you have a city and you remove most of the vegetation from the city and you replace it with asphalt and roadways and rooftops, and which comprise, anywhere upwards of 75% of the area, you've removed this cooling, the natural cooling function that plants perform when the sun hits them, and you've replaced it with surfaces that are often going to heat up and then generate radiant heat up the air around them. Right. So we take away the cooling and we replace it with something that's going to heat up. And all that heating that's going on from the sun, combined with the heat that gets exhausted from buildings that have air conditioning units, because that heat has to go somewhere, right? So it's exhausted from the inside of the building to the outside. So you take that combined with the lack of vegetation, and you get the urban heat island, which could be anywhere from, it ranges based on the city, but it could be anywhere from 2 to, 10 degrees centigrade at worst case scenario, hotter in a city than the surrounding countryside. So then you take that urban heat island and then you combine it with a heat wave, which is hitting Europe right now. And it's like a double whammy. You already have a super heated area, and then you have a heat wave come in, and it's much worse. And that's where people die. And the other thing that happens is that air conditioning units get cranked up above a certain level. I think it's about 22 or 23 degrees centigrade. Every time it gets hotter than that, and these are general statements to apply to a lot of different cities. It's variable, but sure. As it gets hotter, more and more people turn on their air conditioning, right? So when you get to a certain point, everybody's got their air conditioning units cranked up, right? Where is the energy coming from? Are we burning fossil fuels to generate the electricity to drive the cooling? Yes, most of the time we are, right? Yeah. So there's a carbon input, and it's about a 1 degree centigrade above 22, 23 equates to about 4% of what's called peak load demand. So as the temperature goes up above every degree above 22, 23 degrees centigrade, the demand for electrical energy goes up about 3 to 4%. Again, it varies from city to city. So as it gets hotter and hotter, more and more energy, right, has to be produced. More fossil fuels have to get burned. Yeah. And that's your carbon urban heat island connection right there. Bringing in living architecture and collecting water so that we can cool the city with plants we're also able, if we get enough of that happening, and you need street trees, right? It's not just roofs. You need street trees. You need reflective surfaces to deal with the urban heat island. You need plants on rooftops because you take away the heat source, which is the roof, which could be 125 degrees centigrade. These roofs get extremely hot. Yeah. And you replace it with a green roof, it's going to actually cool the building and the surrounding area. So it's like you remove a hot plate, you put on a sort of living air conditioner, you provide it with water, keep it healthy, and it's going to cool the surrounding area. You get enough of those, Chris, in a city, and you can bring the temperature of the city down. You can actually reduce the urban heat island. And we need to start doing that more rapidly than we have been, because climate change projections are that cities around the world are going to get hotter and hotter. And because of outward development, expansion of many cities, they're going to get hotter as we cut down more vegetation. We need to be replacing that with living architecture and green infrastructure in cities. And that's one of the ways we're going to be able to keep cities livable longer in the face of climate change. I've
seen different figures, about 3 to 8%. I think 8% sounds a bit sort of toppy to me, but 3 to 8% of the roofs in Berlin are apparently currently green roofs. What's your vision, for our cities? What can we realistically achieve, and over what sort of timescale?
Well, there's something called Project Drawdown, which is a plan that has been developed to remove greenhouse gas emissions from the atmosphere. And it's comprised of 80 to 100 different measures that can be implemented. And there's a wide range of measures, including a number of them that have to do with women's rights in the developing world and refrigeration systems. It's quite a broad spectrum of things that have been modeled. And they've developed targets for 2050, because 2050 seems to be the number that everybody's fixated on right now. One of the things in there, green roofs are part of the plan. I think it's number 73 on the list, and reflective roofs are part of that as well, because not all buildings can hold the weight of a green roof. And if you can't hold the weight of a green roof, it's better to have a reflective roof, so the sun's energy bounces off the roof and goes back into the atmosphere, as opposed to going into the building or heating up the roof and heating the surrounding area. The target, they've done projections, and their target is 12% of all roofs by 2050.
12%?
12% of all the roofs by 2050, and they've calculated the gigatons of CO2 emissions that would be reduced as a result. And they're the only organization that I know of that have set sort of global targets for green roof implementation. And some cities are on the way to doing that. Stuttgart, Berlin, Linz, I think London certainly is on the way. New York is going down that path, Toronto, San Francisco, just to name a few off the top. I mean, Tokyo's been working on urban heat island issues for some time now. So a number of cities around the world have policies in place that support the implementation of green roofs or require it, either provide financial supports or require it. That space be used for all these public benefits and private benefits. There's the public-private thing. So that would be sort of the dream, is to get to, 12% in as many cities as we can. And, the interesting thing is, Chris, that, the cities that develop and implement policies that utilize the roofs and walls of their building for multiple public benefits are going to be the cities that are going to be the most livable. They're going to be the most desirable cities. They're going to be the most economically viable cities. They may be more expensive cities to live in too, because those two things go hand in hand. People want to go to places where they can have a quality of life. They don't want to be in cities where they can't breathe the air, where they can't go outside in the park with their kids because it's too hot, where they're worried about the water quality, where there's a lack of green space, there's an economics competitiveness component to this that's that's creeping up where, the cities that have their act together, that are forward thinking, that embrace these new technologies and approaches are the ones that will thrive in the face of climate change, and the ones that don't are going to wither and die. There will be mass exodus from them, because people that have the mobility will leave. And, this has been proven over and over again. If you've got the mobility, the economic mobility, you're not going to stay and raise your family in a city that's unhealthy. And our cities are becoming more unhealthy in the face of climate change. So the mitigation component has, it's going to have more and more impact on the future migration of people, not just from climate stressed areas, but people looking for a healthier way to live and be as we continue to go into the 21st century. And my vision is to have as many cities as possible embrace these technologies, so that, we don't have, too much pressure on the leaders, because we already have, lots of pressure, and surely there's a need for more migration from climate stressed areas. I mean, the numbers of climate refugees are going to continue to go up. And, people are, a lot of people haven't sort of fully woken up to the incredible challenge and threat that climate change represents to us, in the near term, and it's like, everybody wants to save money for the future, and we're encouraged to do so by financial institutions and investors and so forth. But if we don't fundamentally start to change the way we, manage ourselves in our cities and reduce our carbon footprints, you have to ask yourself, how much of what's my savings going to be worth, to my children, in 2060, when we're already seeing, they're talking about the summer ice in the Arctic being gone in another 5 years. They're talking about they massively underestimated the rate of melting on the Greenland's ice cap that covers Greenland, and scientists have underestimated the rate of impact from climate change. I remember 30 years ago, this stuff was like 100 years away, right? 150 years. But no, it's on us in a generation. We're seeing a lot of this stuff happen in our own lifetimes. And initially, Chris, they didn't think it was going to happen this fast. And that's not even, bringing into some of the negative feedback loops. You start looking at these feedback loops, and I'll just mention one of them. Like in Canada right now, we have 900 forest fires burning.
Wow.
We have burned a land area in Canada that's larger than Great Britain. We have fires. That's the area has burned, right? Canada is a huge country, but we have burned massive area. They can't get a lot of these fires under control. And the negative feedback, it's not just the smoke. The smoke hits New York and then it hits the front page, right? That was a couple of weeks ago. But all these trees burning are generating greenhouse gases. Rather than the plant sequestering, bringing carbon out of the atmosphere, when you burn the plant, it releases carbon into the atmosphere. So we have forests that have gone from being a sink for carbon, i.e. we're storing carbon there, into a source of carbon. And that's a negative feedback loop, the drying of the forests around the world. And we've got fires in Europe happening now, and Switzerland, and all over the place. Look at Australia a couple of years ago. Yeah. Rather than our forests being something that can help us buffer CO2 emissions, the forests can't do that when they're burning. They do the opposite. So that's the scary part of the equation, is that, we've got to do the best we can to prepare for a very unstable future. But a lot of people think that it's going to be okay. It's all just going to be fine. But that's just not the case. And all of the concerns that people have in the short term for their investments and their portfolios and all that, if they don't use the assets that they have, if they don't put green roofs and walls on their building and invest in renewable energy companies and use the power of global finance to sustain the planetary systems we need, it's going to be game over at some point.
Yeah, I mean, in many ways,
do not collect $100. You know, it's going to be game over. And the people on the cutting edge, they get it. A lot of the people get it, but many, many more people just haven't really woken up to it yet. That this is a really fundamental threat, and biodiversity is the other piece of the puzzle. You know, we cannot survive without a healthy biome on the planet, and yet we continue to chew it up at a rapid rate. So we can use living architecture to some extent to protect rare plants and insects and birds. We're not going to solve the biodiversity problem with living architecture, but we can make a contribution to it as well. Mm-hmm. I haven't mentioned that, but so that's my soapbox for today. We are part of the solution. I
very much see you as part of the solution, Stephen. You know, green roofs and living architecture, and as you know, there is no one magic key. We know that, no silver bullet, but all aspects will go some way to, if not solving the problems that we face, at least helping to mitigate them. And if our audience as well can encourage their pension providers, invest in companies that are making big sustainable gains, making progress on that front, making a difference, then we're all going that a little bit further. It's something I mention sort of quite often, but there's been a number of studies that show how your pension is invested can make 20 plus times the difference your individual actions make. Shorter showers, trains instead of flights, recycling your tin cans. So investing in things like living architecture, green roofing is a major is part of the solution.
Absolutely. And, the thing about that is that, we need to develop a culture where, we're aware, more people are aware that we are facing an existential crisis, climate change and biodiversity loss. And we have all the also social issues that are part of that picture. To plan for a future, like people love their children, they want to leave something to their children. Why not use the every measure possible as an individual to try to make sure that world is there for them, that they can live out their lives and enjoy it. And I think we have as a species the capability to do that. I just don't think there's enough of us yet that have grasped the intensity of the danger. We're really not very good at dealing with the longer term dangers, right? We're very good at the fight or flight. Oh, there's a leopard on the path. We got to run or climb a tree, fight or flight. Yeah. But the climate crisis has been kind of the slow moving dagger heading towards humanity. And we haven't been so good about that. And there's also a lot of vested interests that are trying to make things murky, that benefit from the current system, that don't really want to change or would prefer to be, maybe in denial about it, than to deal with the fact that we do need to change, all of us.
Does your industry have any, bump up against? Does your industry bump up against particularly sort of conservative planners, architects? Is it all good in the hood? Do you get vested interests giving you pushback?
Yes, I mean, we definitely have, had some rounds with some members of the development community. I mean, if you know the bell curve, right? If you look at the classic bell curve, there are early adopters in the first 2 to 3% that go after every new idea and technology as it comes along, and then there's a group that comes after the early adopters and so forth as you go a long time. And then the people at the end of that curve are the people that still have black and white TVs. TVs. They haven't realized that color TVs, better than black and white, like the worst. So for every group, Chris, and every group and dynamic, you have this bell curve, right, of individuals that fall into it. So the trick is to shift the whole curve so that more people are adopting technologies that address the fundamental problems. And the fact is that we can live better lives, healthier lives. It's not like it's all sacrifice. We can have a better, healthier future when we embrace new technologies right now. And personally, we're looking at putting a heat pump in on our house and getting rid of our gas-fired furnace because it's a better solution, both economically in the long term, but also obviously from a greenhouse gas emission perspective. And so I think as more and more people, I think the people are ahead often of the politicians in terms of what they want. And we've seen this in several jurisdictions where the people want more green roofs. They want more greenery. They want access to their waterfront and parkland. They don't want more tall buildings necessarily. So I think the people are in many ways leading the way and will act responsibly if they're given the right information.
Yeah, 100%. And, it's an interesting mix of, the very oldest of technologies and new ones as well.
It is a mix of both, hanging your laundry out, which they do all over the place in Europe. I mean, there are some places in North America where you're not even allowed to do that. You can't put out a clothesline, but it's very common.
You're not allowed to in Germany, I think, on Sunday afternoons or Sundays in general.
That right?
I think.
Some days,
so.
right?
Yeah.
But I mean, what an urban heat island, you get all that moisture that's inside your clothing when the sun hits it, it goes from a liquid to a gaseous state, and it uses up that energy that would otherwise potentially heat up your community. So it might be a good urban heat island strategy, to think about. In addition to a green roof and a wall and a park. And,
maybe that's why some Italian cities, they all hang their washing across the streets.
It's a very cool place to live. I have some colleagues that are actually going into piazzas all around the world, and they're converting them into meadows. They have pathways that go through them, walkways, but they're taking these, concrete stone piazzas, public squares, and converting them into meadows. It's absolutely brilliant and beautiful and has all kinds of benefits for the people. And often they don't want the meadows to be taken away, at the end. But there's so much we can do, to make things better for ourselves and the critters and future generations. We just have to keep working at it.
Yeah, absolutely. I mean, I see so many positives happening out there, and it's. I find myself being sort of quite optimistic, but we do need a good dose of realism to make some of these things happen.
Optimism with a little.
Yeah, well, I think you've given us both today, Steven. It's been an absolute education. It's been so much fun, and I think it's a great industry, and I'm really happy that you came on today. Thank you so much.
Thank you. And if people want to know more, we have a website called the Living Architecture Academy, where we have lectures on the various subjects I touched upon today. It's livingarchitectureacademy.com. Or people just want to know more about green roofs in North America. There's greenroofs.org, and our magazine, which is free and has articles from around the world about living architecture, comes out quarterly. That's livingarchitecturemonitor.com. So there's greenroofs.org, livingarchitectureacademy.com, and livingarchitecturemonitor.com. There are free resources on there if you want to learn more about what we're doing, and hopefully you'll get a green roof or a wall on one of your buildings up soon.
And again, I can back that up. I've been on all those sites and educated myself a bit too. And for individuals that want to get a green roof or that want to push their local authority or their company to green their space, what's the best way of going about that?
Well, I think depending on which country you're in, I mean, I would do a Google search. If you're in the UK or Spain, there are green roof associations and wall associations in, I think, virtually every country in Europe, as well as in Asia. They're in Taiwan and China and Indonesia and Australia and New Zealand, just to name a few. So, I think that's probably a good place to start, is to find your industry association, because then you'll find some companies and some design professionals that can help you go down that path.
Yeah, of course. Brilliant. Stephen, thank you so much again. Love to have you on here again at some point in the future. You've been an absolute pleasure and a complete education.
Thanks for having me, Chris.
Thanks, Stephen. Take care now. Bye-bye.
Thank you.
So the green roofing market is currently valued at around $1.4 billion. It's expected to grow at about 400 or 500% over the next 7 years, currently growing at about 16% per annum, and that's expected to continue well up to 2030. So it's a significant industry. We've heard from Steven Peck of the massive social, environmental effects it can have, and the consequences for costs as well, costs of heating, energy costs, the value of properties that can be improved by it, making our cities and spaces attractive to live in. So there's a lot of opportunity out there. What can we do as investors? Well, we mentioned the fact that investing has a massive effect on sustainability in general. But how can we specifically get access or exposure to the green roof market? Well, there's, I think, sort of 5 or 6 different ways we can do that. One is sort of through direct investment in green roofing companies themselves. You have examples like Sika, Swiss specialty chemicals company, which offers various products and solutions for green roofing, waterproofing, construction. Tremco, for example, is a roofing company that provides sustainable roofing solutions. Green ETFs will often give you exposure to green roofing installations as well, through there are various well-known common ones like Invesco Solar, known as TAN. The iShares Global Clean Energy ETF, ICLN, will give you exposure to a wide range of clean energy companies, including those engaged in green roofing technologies. There are green infrastructure funds like GLIL, UK-based infrastructure investment fund that may include green infrastructure projects like green roofing. You've got Greencoat UK Wind PLC, mostly focused on wind energy, but it's also an infrastructure fund with a strong focus on renewable energy assets, including green roofing. There are green bonds. Ford, for example, issued green bonds to fund environmentally friendly projects, which include initiatives aimed at things like green roofing and green spaces. Unibail, Rodamco Westfield Green Bonds, is a real estate investment trust issuing green bonds to finance sustainable real estate projects, which many of which include green roofing or living infrastructure. There are deliberately or specifically sustainable real estate investment trusts like Helen Armstrong and other green real estate investment trusts. So, look out for those that have exposure to green buildings, sustainable properties, and living architecture in general. The green roofing sector is gaining considerable traction. Do note, though, that the investment landscape can change very rapidly. Always conduct up-to-date research, consult your financial advisor or investment analyst before making any investment decisions. These are just potential investment avenues in the green roofing sector, and those are just examples. So do your own research. Remember, things change very rapidly. The environment changes rapidly. Green roofing is a great way to make a small dent in the climate crisis and give yourself the opportunity to improve your financial future at the same time. Thank you so much for joining us today. This is Chris Everett on Green Money Matters. Join us next week, where we'll be looking at other really fascinating ways of improving our financial futures and our environment.
If you enjoyed today's episode, be sure to subscribe to Green Money Matters on your favourite podcast platform. and never miss an opportunity to grow your wealth sustainably. Together, let's make money matter for the planet.
And don't forget to leave us a review. We really would love to hear your thoughts or ideas for future episodes. Drop me a line by email at chris@greenmoneymatters.com.
Stay tuned for our next exciting episode, where we'll explore groundbreaking investment opportunities and unveil the secrets of successful, sustainable investors.
Until then, remember, green money matters because investing in our planet's future is the smartest investment choice you can make. Thank you for joining us. Until next time, goodbye.